Okay guys, so in this video let's talk about linear search. Okay, so the topic is linear search. Okay, so it's very easy actually. So let us take an example to understand this algorithm, right? So another important point is linear search is also known as sequential search. Okay, because we're gonna search the array sequentially. That's why it's called as sequential search. Okay, let us take an example. Let's say this is my array. Alright, so I have elements say 1, 2, 3, 4, 5 and 6. So I have 6 elements, okay, and the corresponding positions are 0, 1, 2, 3, 4 and 5. Index, right? So index starts from 0, you know that, right? Alright, so let's say I am searching for an element, I am searching for an oh my god, let's wait. Recording, yes. Okay, so yeah, let's say I'm searching for an element, say 5. Okay, searching for element 5 in this particular array. Okay, so what I have to do here is basically I have to start from the let's take another color. Okay, so I have to start from the very first element in the array. Say very first element is 1, right? I have to compare whether my this element equals to 1. It is not true, right? So I have to move my cursor to the next particular element. So now I have to compare my whether my element equals to the next element. It is not true. Okay, so that's it. Okay, it is not true. So I have to traverse to the next element. So I have to compare whether that is my searching element. So that is not true, right? So this is not true, and I just comparing the other element, and that is also not true. So if I reach that particular element where I'm searching for, then I'll say 5 equals to 5. That is true, right? So the idea here is search until the element is found. That's it. Very simple. Search until the element is found. Element is found. All right. Okay, so always start from the first element, move towards the last, start from the first element, move towards the last, and search for your element, right? And one more important point I wish to insist here is you have to use for loops, of course, because you are traversing through the arrays, right? So you have to use for loop. Only one for loop I'm going to use, right? Only one for loop. I think you would have guessed the pseudo code. So the code is very simple. That it goes like this. I'm starting from the first element. Okay, so I'm starting from the very first element, which is the 0th element, and I am moving through the array. Now while I'm moving, so inside this for loop I can write code, right? So it's very simple. Okay, just a minute, hold on. Okay, right, I just have to compare, right? I just have to make comparison using if statement. I'll say if a of I, let's say a is my array. So if a of I is equal to the element I'm searching for, okay, if it is true, then what I'm going to do is I'm going to print, okay, I'm going to printf element found, okay, element found, and I'm going to break the loop. That's it. Okay, because I don't want to uh, you know uh, I don't want my loop to run again because I have already found the element, right? So I just have to break the loop. That's it. Okay, it's very simple algorithm. So you just have to search, and if the element is found, just break the loop. That's it. It's a very simple one. That's all about linear search. And since you have only one for loop, the time complexity is O of n. Okay, the time complexity is big O of n. So the worst case time complexity, the worst case time complexity is big O of n, whereas the best case would be big O of 1. Why? Because let's say I'm this is my array and I am searching for element 1. Okay, that's the best case. Okay, you must know where the best case will come. The best case will come if you are searching for the very first element, right? Let's say my first element is 10. If I am searching for 10, then the best case would come, because there is no need for me to traverse the loop, right? All right, so I can stop the very well stop the loop here itself. The element I'm searching for is the very first element of the array. Then I just have to execute it only one time. All right, I can directly get the element, right? There is no need for me to traverse through the array. So the best case time complexity goes like this: O of 1, big O of 1, and worst case time complexity is big O of n, and n denotes the size of the array. Okay, size of the array. So maybe if the array is big, then it would take a very long time to locate the particular element, right? So that's how it goes. Thanks a lot.